Welcome to lesson 7.3, the discriminant. So if we're going to talk about the discriminant, the first thing we need to do is define what is the discriminant. So if you'll recall from our last lesson on the quadratic formula, that if we have a formula in the form ax squared plus bx plus c equals 0, then we get two answers for x, negative b plus or minus square root of b squared minus 4ac all over 2a. So the discriminant is really this piece of the quadratic formula, this piece that is underneath the square root. So when we write the discriminant, it's going to start the same way. If ax squared plus bx plus c equals 0, then our discriminant d is going to be just the part under the square root, b squared minus 4ac. So, why is this idea, this discriminant, a useful quantity? Well, let's talk about what happens in various cases. So, if this discriminant is less than 0, if it's negative, then what that means is that underneath the square root we have a negative number. So our answers are not going to be real. We're going to get some quantity with I for this square root, and we're going to add it and we're going to subtract it. So we're going to get two answers, and they're going to include an imaginary number as part of them. So they will be complex numbers, not real. And our answers, when we solve an equation where one side equals 0, the answers are called roots. So when our discriminant is negative, that tells us that we're going to get two complex roots. Now, what happens if the discriminant equals 0? That means we're taking the square root of 0, which is 0. And when we add 0 and subtract 0, we'll get the same answer. So now we don't have two answers, we have one answer. It will be negative b over 2a, so a real number. In fact, not just real, rational. And it somehow counts double because it counts for the plus and the minus. What happens when our discriminant is positive? Well, that means we're adding and subtracting some quantity. So again, we will have two answers. They will both be real numbers. And there's a little bit more that we can learn. In this case, if our discriminant d was a perfect square, then the root of it will be a whole number. And now, when I do this calculation, I will get a rational answer. If this discriminant d was not a perfect square, then the two answers we get will be irrational. So let's put this into practice on an example. We want to find the values for k, for which some equation is going to either have a double root, two unique different real roots, or imaginary roots. So I can figure out what kind of root we have based on the discriminant. So I'm going to start by calculating this discriminant. So my discriminant, b squared minus 4ac, in this case my b is 12, so 12 squared minus 4 times my a, which is k, times my c, which is 9k. So I'm going to get 144 minus 36k squared. So, if we want a real double root, then that means my discriminant is 0. If we want two unique real roots, that means my discriminant was positive. If I want imaginary roots or complex roots, that means my discriminant was negative. So let's go and do this calculation. Discriminant equals 0. So 144 minus 36k squared equals 0. I will add 36k squared to both sides. I will divide by 36. And now, by taking the square root of each side, I will find that there are actually two values for k. I have positive 2 and negative 2 that will make this discriminant equal 0. Now, since I already know when the discriminant is 0, I can use that to figure out when it is positive and negative by plotting these numbers on a number line. So now I can test points in each region. I know the discriminant is 0 here and 0 here, so I want to know what is it in between. What is it on each side? So the first point I'm going to test is when k is 0, because that's right in between negative 2 and 2. Well, 0 squared is 0, so I'm not subtracting anything from 144, so I will end up with a positive answer. Over here, if I test 10, that's usually pretty easy to plug in. 144 minus 36 times 10 squared. 10 squared is 100, so we're subtracting 3,600, so I'm going to get some negative number. And on the other side, let's test negative 10. That's usually pretty easy to plug in also. Well, negative 10 squared, again, is 100. So I'll get 144 minus 3,600, and I will get a negative answer again. So what is this telling me? If I want to know where is the discriminant positive, well, that's right here, in between. So I want k values that are in between negative 2 and 2. So I don't want to include negative 2 and 2. In those cases, my discriminant equaled 0. I'm in a different case. If I want strictly positive, I will be in this region. If I want to know where is my discriminant negative, that's these two places. So that's going to be k is less than negative 2, or k is bigger than 2. So that's how we can use the discriminant to figure out how many answers and what kind of answers we will get when we solve a quadratic trinomial.